Assalamualaikum warahmatullahi wabarakatuh. My name is Nino Azlin binti Nilin with metric number AE180012 from group F3-6. So I'm going to explain about activity number 1. So this is our first block diagram, and we can run our circuit, and then we can if we see here our we can see here it's 240, and we can get our input voltage over here. This is our graph. So our input voltage is 240 volt, and this is our graph for motor top, which is our value is 46.93, and this is for our motor speed. This is the graph, and our value is 369.5. and then the last one is our tachometer. So this is our graph for tachometer. Our value is 240.2. So for the second block diagram, we need to add tachometer constant over here, and then we can change our input here. We're going to change for the first value. We need to change it to 8 different values, and for the first one is 400, and we can run our circuit again, and then we can get our input voltage here. So our input voltage is 26. This is the graph for the input voltage, and then for tachometer is this is the graph for tachometer, and the value is 26.02. So the difference between input voltage and tachometer is just tachometer has 0.02 at the back, but the input voltage didn't have 0.02 at the back. So we need to change our input voltage here, but as I already done, so this is the value for input voltage, and this is the value for tachometer, and this is our graph. So this is the graph for input voltage, and then this is the graph for tachometer voltage. Okay, that's all from me.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mishra binti Mak Samri. Umati sekarang both AE180035 will be explaining to you briefly about the activity 2 simulation. So this is the open loop control system diagram that has been constructed using the same circuit as in activity 1, where the parameters remain the same except for the input speed. So the input speed is set to 2500 RPM to record the input voltage value. So I've already simulated this, or otherwise my laptop will hang. So as you can see, the input voltage recorded is around 162.5 with the this is the graph that the input voltage is constant at 162.5 at the sample base 10 seconds. And the speed output, as you can see, is around 2500 RPM, and this is the graph 2500. And then the tachometer output graph is around 162.5. So next I will do the next simulation. Okay, so this is the activity 2 simulation part 2, where the input speed is now set as the direct supply, which is this 162.5 volt. And as you can see from the previous activity, now the tachometer constant is removed from the open loop control system. So the break scale is varied from 0 to 21. However, in this simulation, I only show you break scale that is set to 21. So this is the speed output that is recorded, which is around 884.6 RPM. And this is the graph for the input voltage, which is constant at 162.5 volt. This is the speed output graph at around 884.6, and this is the tachometer output. So the process is repeated from braid scale 0 to 21. So later I will show you the recorded values in the Microsoft Excel environment as well the graph. Thank you. Okay, so this is the simulated data of the motor speed that has been recorded for each braid scale, where the highest motor speed recorded at 0 braid scale and the lowest motor speed is recorded at 21 braid scale. So this is the graph that illustrates the relationship between the motor speed versus the braid scale, and as you can see, the relationship depicted a decreasing linear relationship between the motor speed and braid scale.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nuhdaya binti Nusham. My matrix number is AE180056. So now I would like to do and explain for activity 3, closed loop speed control system. In exercise 8, open loop and closed loop speed control system. So first I have to construct the closed loop speed control system block diagram in MATLAB Simulink. So here is the block diagram, and then I have to set the parameters according to the list given in the lab sheet. After that, I have to fix the input value. The input voltage value obtains in step 1 activity 2. So here is the input voltage value 162.5, and also I have to set the time at 10 seconds. So after setting all the parameters, I can run the simulation to obtain the motor speed value according to the brake value, which is 0, 3, 6, 9, 12, 15, 18 and also 21. Okay, after that I also have to show the graph obtained. Okay, first we have to set the brake value to 0. Okay, in this simulation presentation, I would like to present for 3 examples only, which is 0, 3 and 6 for the brake value. Okay, now the brake value is 0. We can run. So the motor speed in RPM value obtained is 2488. And then the graph is the pattern of the graph obtained is okay. This is the pattern of the graph. Okay, after that we can change the brake value to 3 and then run the simulation again to obtain the motor speed in RPM. So this is the value of motor speed for brake value of 3, and then the graph is like this. So the pattern of the graph is slightly different from just now. Okay, now I would like to change the brake value to 6. Okay, we can run the simulation. Okay, this is the value obtained for motor speed in RPM 2485. Okay, we can observe the graph obtained. The pattern is slightly different because the motor speed in RPM value is also slightly different. Okay, I think that's all from me. Thank you.